All right, so 6.3, basically these are going to be converses of what we did previously. So last lesson, we were given that it was a parallelogram, so what could we assume? This time, what information will prove that we have a parallelogram? So first one, just a reminder, the definition of a parallelogram. So if you have opposite sides are parallel, that's going to imply that we have a parallelogram. If you have opposite sides are congruent, then we will have a parallelogram. If we have opposite angles are congruent, that implies that we have a parallelogram. And if we have diagonals bisect each other, that implies that we have a parallelogram. So all of those are converses of what we did in the last lesson. This next one, though, is new. This one says one pair of sides are parallel and congruent. What that looks like is if I know these two sides are parallel and they're the same length, then automatically that's a parallelogram. Okay, so that's the only new one. Okay, so we want to determine whether each quadrilateral is a parallelogram, and then we want to justify our reason. Again, it's going to come from that table above, and we're just going to pick which theorem matches. Okay, so first thing, what we want to do, we can see opposite angles are congruent, but we also need to make sure, are the consecutive angles supplementary? So we just double check 65 and 150. Yeah, that works out. So our answer is going to be yes. And our reason is going to be opposite angles congruent imply that we have a parallelogram. All right, next one. We have to determine yes or no. Now in this one, I see that these two sides are marked congruent, but the only other thing is that we have these angles. However, just like when we had information previously, like when we were proving triangles congruent, if you have something like these would be considered alternate interior angles, that is going to make these two lines parallel to each other. All right. So even though those weren't labeled as parallel, we can make that assumption based on the converse of the alternate interior angle theorem. So this one is a yes. And the reason is one pair of opposite sides are parallel and congruent implies that we have a parallelogram. Okay. This one. Now, what's interesting in this one, they labeled alternate interior angles, but they also put the arrows in. Okay, so that's not really, they kind of gave us the label at the same time. But then they marked these two sides congruent. We have to make a determination. Is that enough information? And it is not. Okay, what we need to know is we would need to know if this line and this line are congruent, and that we do not have that information. Okay, so this is not possible. Not enough info. Okay, and so now the next couple problems are going to look similar to what we did in the previous lesson. We're basically finding x and y so that the quadrilateral is a parallelogram. So we want to make certain things equal to each other or supplementary and so on. Okay, in this case, I've got to make these two sides congruent. So 6x minus 12 equals 2x plus 36. Again, you can always pause it and then see if you get the same answers as me for practice. I get x equals 12. And then for the other two sides, I know 6y minus 42 is the same as 4y. And so I get y is 21. Okay, take a look at the next one. Again, if you want to try this one on your own. Otherwise, let's take a look. I know 56 and 7x have to be the same. So x equals 8. And then I need to make sure these two angles are congruent. So I have 5y minus 26 equals 4y plus 4. So we get y equals 30. Okay, the last two examples, we want to figure out whether or not we have a parallelogram. And it says use the method indicated. So in this one, it says slope formula. Let's go ahead and sketch a graph. So here's B at 0, 0. C is at 4, 1. D is at 6, 5. And E is at 2, 4. Okay, so it looks like it could be a parallelogram, but we want to make sure our slope formula, just a quick reminder, y2 minus y1 over x2 minus x1. And what we basically want to show, we want to show opposite sides parallel, okay, which means they'd have to have the same slope. If that's true, then we know it's a parallelogram. Okay, so let's do ED. The slope of ED, so I'm just going to focus on these two, right? So I'm going to look at, so I have 4 minus 5 over 2 minus 6. So that's going to be negative 1 over negative 4, or 1/4. Okay, and I want to check to see, is that going to be parallel to BC? So now I'm looking at these 2 points. So I have 1 minus 0 over 4 minus 0, which is 1/4. Okay, so that checks out. Those are parallel. Now we'll check the other two sides. So I'll check EB. So now I want to focus on E and B when I use my slope formula. So 4 minus 0 over 2 minus 0, so that's going to give me a slope of 2. And I want to make sure that DC on the other side, so now those 2 points, let's see what I get for M, 5 minus 1, 6 minus 4, so that's going to be 4 over 2. Good, so those check out, and those are both the same. Okay, so we'll just say yes, B, C, D, E is a parallelogram. Okay, one more last problem here. We have E, F, G, H. Let's go ahead and graph it first. So E is at negative 4, negative 3. F is at 4, negative 1. G is at 2, 3. And H is at negative 6, 2. Okay, this one looks a little bit off, but we got to verify it. And so now it says midpoint formula. So we don't want to find the midpoint of the sides, but if you remember, one of our formulas, or sorry, one of our theorems was diagonals bisecting each other. So if diagonals bisect each other, that means the midpoint of that diagonal has to be the same midpoint for the other diagonal. So if I just find the midpoint of the diagonals, so let's do first the midpoint formula, just a quick reminder, is x1 plus x2 over 2, y1 plus y2 over 2. And again, we want to show the midpoint is the same for both diagonals. Now what's nice about this is, remember with the slope formula we had to do that 4 times? Here we have 2 diagonals, so let's look at EG. Let's find the midpoint of EG. So I'm focusing on this point and this point. So I have -4 plus 2 over 2 and -3 plus 3 over 2. Okay, so that's going to be -2 over 2, so that's -1, 0. And now let's see HF. So I'm now focusing on these 2 points, and I want to find that midpoint. So I have 4 plus -6 over 2, and -1 plus 2 over 2. So we do get -1, so it has the same x coordinate, but the y coordinate is 1/2. And so because these are not equal, GH is not a parallelogram. Okay, and that is it for this lesson. So again, go ahead and continue on the Pear Deck slides, and then you'll see your worksheet for homework. And again, if you ever have any questions, you can stop by at Bonus or see the Math Center in the evening.